start our discussion of geometry with triangles. Let's start a discussion on triangles. It's one of the most important topics in geometry. We know what a triangle is. It is a three-sided closed figure, and we know that the sum of all the angles of a triangle is 180 degrees. So we have used that extensively before in school, and we'll continue to use it now. All right. Now, the sum of any two sides of a triangle is greater than the third side. Now, does this work? Why is this true? All right. So let me make a triangle. Let me make a triangle of, let's say, I say that the lengths are 3, 4, and 5. Okay, so this is a triangle. Don't worry about it. 3, 4, and 5, right? All right. So then what happens now? 3 and 4 is total is 7, and of course it is greater than 5. Now, if I want to make the sum of these two sides, of the 3 side and of the 4 side, smaller, what will I do? I'll make this smaller. Let's say I've brought it as at 2.5 and I've brought this at 3.5, right? I still have a triangle. Now the lengths over here are 2.5 and 3.5. The total they add up to 6, and this line is still 5. Now I want to make these lines even shorter, right? Because I want them to be equal, the sum to be equal to 5. So then what happens when the moment I make these lines of length 2 and 3, now 2 and 3, they are going to lie flat on this line over here, right? Now they cannot rise up. Now 2 and 3 will lie flat on the 5 line because 2 and 3 adds up to 5. So then now they can't make a triangle at all. So that is the reason why the sum of any two sides of a triangle is always greater than the third side. Okay, let's assume that I have a triangle where two sides I know are 4 and 5. All right, so then let me put down one of the sides. I say this is 4 and let's say this is 5, right? 5 is of course going to be a little longer than 4. So what about the third side? Look, since this side is 5 and this is 4, then the third side, I just realized, is going to be slightly greater than 1 for sure. So then this has to be a little more than 1. The third side will need to be slightly greater than 1. I've tried to keep the angle really, really small over here. That is why it doesn't need to be really long, but it has to be a little more than 1 for sure. All right, now what happens when, again, I have the same side of 4 lying down, but I pull my side of 5 a little up, right? I increase the angle over here. I increase this angle, right? So then what happens to my third side? It gets a little longer. So let's say it has become 2 now. All right. Now what happens when let's say, again, it is the same at 4, and now I pull my 5 a little more up. This angle is even greater now. Now I get a side over here of 3 centimeters, right? Now this becomes 3, 4, 5. We know this is a right triangle. I get a right triangle of 3, 4, 5. This is an obtuse triangle. This is an obtuse triangle. What is an obtuse triangle? It has one angle which is greater than 90. So this angle is greater than 90. This angle is also greater than 90. Now as I keep moving my side of 5, length 5 up, now I get a 90-degree angle, right? And the side over here is now 3. All right. Now what next? Now say I have my same 4 over here and I move 5 even further up. So here now my angle has increased even more. This is my 5 and this is my 4. So now the length of the third side has also increased even more. So the length of the third side could have gone up to 5, right? Now what I have is all the angles are less than 90. I've got an acute triangle. All angles are less than 90 in an acute triangle. Of course, in a right triangle, only one angle can be 90, two cannot be 90. because the sum of all three angles must be 180. So if we have two angles which are 90 each, then the sum becomes 180 and the third angle becomes 0. That means we don't get a triangle at all. And of course, in an obtuse triangle, only one angle can be more than 90. Since the sum is 180, you can't have two angles more than 90, right? So here now, coming back to this, now the third side has become 5. Okay, let's go ahead further. Now let's say again here is my 4, and now I make my 5 stand straight like this. Right? It's okay. This is 5 and this is 4. We don't have space, so that is why 5 looks shorter than 4, but let's not worry about that. So now this is my third side. Right? Now the length of now again my angle over here has become 90. Initially my angle over here was 90, right? This was 90. Now this has become 90. And the length of this would be root of 25 plus 16, that is root of 41. Right? Okay, now what next? Now I'll keep moving I'm moving my this side, which is a 5 centimeter, this one. I'm moving this slowly up, right? I'm going up slowly. Now my side of 5 centimeters has reached here. Of course, I'll now continue and keep going down. So let's say now if this is my 4 centimeter side, and this is my 5 centimeter side. Now the angle is again greater than 90 over here. It's become an obtuse triangle here, and this has become a really long side. The third side has become extremely long now, right? All right. So then notice what has happened. Initially I had an obtuse triangle where my third side was very little. It was just a little greater than 1. 1 being the difference between 5 and 4. It had to be greater than 1 because some of the two sides have to be greater than the third side. So if this were 1, then 4 plus 1 would have become equal to 5 and I couldn't have made a triangle. So initially when I started out, I had an obtuse triangle and my third side was slightly greater than 1. Then my third side was again a bit greater than 1. Then I got a right triangle. This angle became 90 degrees, and that is why my third side became 3, right? Then here, what is the relation over here? Here, a square plus b square is equal to c square, right? Here, let's say if my 3 is a and b is 4, then this is equal to c, right? And the right triangle, a square plus b square is equal to c square. Over here, look at that. Let's say when this was 4 and this was 2, and this we knew was 5, then 4 square is 16 and 2 square is 4. So 16 plus 4 is 20. My third side square was greater than, so 25 over here, right? 5 square is greater than 4 square plus 2 square. 25 is greater than 20, right? Makes sense. So when I had an obtuse triangle, then the squares of the sum of these two sides was less than the square of the third side. We're talking about the squares, not just the sides, right? So in an obtuse triangle, a square plus b square is less than c square, right? Here, this is an obtuse triangle. This is a right triangle. Then what happened? Then I got an acute triangle, right, where all the angles were less than 90 degrees. Now here, my 4 square plus 5 square is greater than 5 square. So now a square plus b square has become greater than c square, the third side. Third side as in the greatest side. Then again, we got a right triangle when we kept moving my 5 centimeter line around. So then the third side became a length of root 41. Now, when I have a 4 centimeter here and a 5 centimeter here, this has become longer now, right? Let's say maybe this is 7 centimeters. Now, when I have, let's say, 4 centimeters here and my 5 is almost flat along with 4, then the third side will become almost 9, right? The sum of 5 and 4, but not quite. It will not become 9 because it cannot be equal to 9, but it will be just slightly less than 9, the third side, when I have this 4 and this 5. There has to be an angle. This angle between them cannot be 180 degrees. To make a triangle, there has to be an angle, right, between the two sides. But then I'll make it as great as possible, but not 180. So the third side, length of the third side would not be 9, but almost, right, just less than 9. So when I have two sides given to me, 4 and 5, the length of my third side, it goes from greater than 1, slightly greater than 1, up to 3, up to whatever, 4, 5, etc. Then up to root 41, then on and on up to almost just less than 9. So from the difference, from a little greater than the difference between the two sides to a little less than the sum of the two sides is the length of my third side, right? And notice that I start with an obtuse triangle over here. Then I go on to right. So I start with obtuse. I go on to a right triangle. Then I go on to acute. Then I get again a right triangle. Then I go on to obtuse yet again. So when can I make a triangle? What could be the lengths of the sides? Let me demonstrate by taking two straws over here. Now these two straws are of equal length. They're both 10 centimeters. And I bend one of them to give me two lengths of 5 centimeter and 5 centimeter each. Now can I make a triangle of two sides 5 centimeters each and the third side as 10 centimeters? Let's see. Look over here. This vertex is not joining this vertex. For that, to make a triangle, I need the two to join. All right. So then what can I do? I can increase this angle. So from here, let me start increasing the angle to try and reach that vertex. Let that be the third vertex, right? So now on and on and on. And when will it reach the vertex of the third side? When will these two come together? They'll come together when this angle becomes 180 degrees, when it becomes a straight angle. But now we don't have a triangle, isn't it? So that means if I want to make a triangle, the length of my third side, it has to be less than 10 centimeters, the length of the other two sides together. That is how we get that the sum of two sides of a triangle has to be more than the third side. So given two sides of a triangle, what could be the third side? Well, it could take lots of different values. Let's figure out what those values are by bringing back our straws. Let's say I have these two sides of the triangle defined. This is say 3 and this is say 5. So now we'll keep varying the length of the third side. So let's say I bring this really, really close together. And then the third side would be almost 2 centimeters, right? If this one is 3 and this one is 5, then this would be almost 2, but it has to be a little more than 2, isn't it? Because the sum of 3 and 2 has to be greater than 5. So it can't be 2, it has to be a little more than 2. And this will give me an obtuse triangle. Do you see that this angle is a greater than 90 degree angle? All right. Now, let me increase this angle a little bit. And now the length of my third side has increased. Now let me further increase this angle a little bit and the length of my third side has increased even more. Now, when I come over here, the length of my third side has become 4. This has become a right triangle, right? This is 3, this is 4, and this is 5, the hypotenuse. All right. Now let me increase the angle a little more. Now I get an acute triangle. You see, all the angles are less than 90 degrees. Now, further I increase this angle, again, acute triangle. Further I increase it, I again get a right triangle. But now my third side is the hypotenuse. This is 5 and this is 3, and they are both the legs of the right triangle. So this becomes root 34, right? So then the length of the third side is root 34 now. All right, let me increase this angle a little more. So now the length of my third side has become even more. And note that it has become an obtuse triangle yet again. This angle is more than 90 once again. Let's keep going. Now, as I'm increasing the angle, look at that, the length of my third side is increasing on and on and on till it is almost equal to 8, but not quite, right? Because this plus this is 5 plus 3. Now, the third side has almost become equal to 8, but it is still going to be less than 8, isn't it? If we want to make a triangle, then it can't be 8. All right. So now what happens? Okay, tell me now, we started with an obtuse triangle, went to a right triangle, then acute, then right again, then again obtuse. Now what if I keep going? Let's say if I turn down over here. So then here is where my third side will be, right? And the length of my third side will again keep going down. Now look at that. Again, I've got an obtuse triangle, but in the other direction. Now I'm going down. Again, I get my right triangle, but it is flipped. So basically, when I move from here to here, all that has happened is that I'll still get the same triangles, but now on the other side, they'll be flipped, right? So look, the length of my third side will again keep decreasing till it goes to almost 2.